Welcome to Robotics Class 2 or Lesson 2. We're basically going to cover Arduino, widely used board for robotics, very popular. This is the, they have several different models. This is the Arduino Uno. Also, going to cover some of the stuff in Chapter 2 in our book, a robotics book fun with robotics, Arduino, and Raspberry Pi. It's free right now for this pandemic stuff. Go to bridgewaytech.org for more information. All right, so this class will cover all the basics, everything you need to know to get started and have fun. So let's see what else. It's going to be about 12 classes in total, and they'll be available to view on bridgewaytech.org. So let's get to it. So the Arduino, bringing up the Uno, they have another one, Arduino Nano, which is one of the newest ones. It's like half the size of this. Of course, having a smaller one has several advantages for different projects. If you need something light, put it on a drone or something. And it has the same functionality, same code, and all that good stuff. Basically, all of them, the operating voltage is listed as 5 volts, but it's better if you put 9, at least 9 volts, because as you add components to it, it drains the power and the voltage. So things work better if you have 9 volts. They recommend 6 to 20 volts. So 9 volts, it's way within tolerances. As you can see on this list, the operating voltage is 5 volts. So the board itself, the components work on 5, but when you add other stuff, it's better to have 9. And you will be adding other things like, different sensors. And this is the same board that we use on our kit. Actually, I just took it out of the kit. Okay, so 9 volts, ideal. Doesn't use much current. It says in the specs, 20 amps, 50 million, 20 milliamps, 50 milliamps. So that's very low current. It also, one of the cool things about it is when you write your sketch or your code, in Arduino language, they call it sketch. Same as code, program, whatever you're used to. And the once you put your code in here and you disconnect, turn off power, it stays in here. So that's a nice little feature. It's an advantage to do that, so you don't have to always constantly reprogram it, or program it, run a program. All you gotta do is power it up and it'll behave the way you programmed it last. There's the flash, so it's actually it has flash memory, and that's where the sketches are stored. And it has how much? 32 kilobytes, which usually is a lot. I mean, enough. It's not a lot in these days, but basically we have simple functions, and code is very efficient, so it doesn't use that much room. It also has EEPROMs, 2 kilobytes of that, which is electrical erasable memory. That's also non-volatile, meaning it doesn't disappear when you turn the power off. So that's important. That stores data stuff. And basically the CPU, or the computer processing unit, is 80 mega. 18 mega 2328B P. 18 mega 328P. Say that fast a few times. And the clock speed, 16 megahertz. And it says LED built-in 13. It's kind of misleading. Doesn't mean they have 13 of them. It means that I don't think it has that many. 13 is actually the pin number that the LED is connected, and we'll see that later. It's a dedicated pin for the LED on the board. And we're going to play around with that. It's going to be our first program. And it weighs 25 grams. So it's not heavy at all. So to do this, you need a laptop, some type of computer. It works on Macs and Windows. For those of you with tablets, you could Google it, how to connect to a tablet. It connects to some, and there's steps on how to do that. We're not going to cover that. You need it only works with certain types of tablets. And the other thing is there's actually, although you need a computer for this too, so that doesn't help. They have 2 ways of doing this. The software, you could download it to your laptop, which I recommend that at least later on. You can try they have this new web-based tool. You can run everything on what they call the cloud, everything remotely on their stuff. And it's all free. You go to Arduino.cc and you'll see all the information. And we're gonna actually do some of that process. I waited to upgrade. I've been doing this for a while, so my software is already outdated. And they have upgrades, so I waited to upgrade so I could demonstrate. It's pretty straightforward. So you need that. It also usually comes with a cable like this. One end is USB, goes into your computer, and the other end has this weird connector. For those old timers like myself, we remember this from printers. And this for the Arduino Uno. The Nano uses a different interface, uses a more, I guess, modern connection. And it's going to go in this slot here. That's where this goes. So this goes there, and the other end goes to your computer. So, let's see, what else did I basically covered all of that. And actually that's in chapter 2 of the outline. And let's see, and the tools that we need, not much. Basically, I talked about that. For the kit itself, you'll need a screwdriver, small screwdriver, maybe long nose needle pliers, or any kind of little, what do they call those things that they use? Little pliers or something to hold these small screws. But I mean, you could do it with your hand too. Tweezers, that's the word I was thinking of. Tweezers are helpful. And basically the kit is just you screw in connections. There's no soldering involved. So if you buy another kit other than ours, one thing to look out for is if there's any soldering necessary. The other thing is this is actually Arduino clone, which is a lot cheaper than the regular. However, some of the clones don't work well. They take a lot more effort to get it to connect. In our kit, we use the clones that are just like Arduino and straightforward. And because there's a lot of components to keep the price down, we use the cheaper kit. But when I started, I bought the Arduino board from Arduino. It's about $35, which is not bad. And that works flawlessly. It's a better made board also. But like I said, in our kit, to keep costs down, we use a clone, and it's pretty durable. It's 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 pretty good. It's also probably just as reliable as the Arduino. Now the thing is, interesting thing is the way Arduino was put together. It's done by universities in Italy, and because it uses public funds, it's open source. So they'll show you exactly how this board is made. You can make the board yourself if you're so inclined. You buy the components, and they show you how to do all that. It's all the schematics, which is a diagram of how all this stuff is connected. It's all available. So that's why other people, of course, are making them, and you can make it cheaper. But the good thing about buying from Arduino is that you support their efforts. So, and of course, the good thing about buying the kit from us is that we are familiar with all the components, everything works. And the other key thing is we have very good technical support. It's online, there's a forum, you can email me. And also the class covers it. And the connections are there's no soldering involved, and it's relatively inexpensive. So this all the pluses, and it's not, you'll find kits that are similar but not exact. So I chose different components that I know work best from doing this for several years and building several different kits. Okay, so enough of that. Let's get to the software. So let me share. Let's see if I can share this screen with you. This additional screen. So if I go, right now I have it installed already. So if I go to my start menu, my Windows, and I select Arduino. Now I see it's not sharing, so I'm gonna have to do a new share for that. New share. So now I'm sharing the screen, and that should work better. So I go to start, I go to my Arduino install. Now you won't have this yet, but I want to do this because it's going to ask me if I want to upgrade it. And so it's bringing up the Arduino development environment. And it takes a few minutes. You know how I'm running a lot of stuff. This the interactive software I'm running slows it down. So once it brings it up, it's going to ask me, oh, in this case it didn't. That's interesting. I guess because it got tired of asking me. Yesterday, it asked me if I want to upgrade. So let me go to Arduino site. Let me close this Arduino thing. I'm going to have a problem if I don't, when I try to upgrade it, most likely. So let me close that. And let me go to Arduino.cc. Arduino.cc. It's based in Italy, so I guess that's why it has a kind of weird ending instead of .com, .org or something. And I encourage you to go to the site. It has a lot of cool stuff. There's a community, a worldwide community. They have all these resources, how to get started, which I would read that. And it has help. It has a lot of projects that people do on the community hub. There's tons of really interesting stuff. Actually, on there, I saw AM/FM shortwave radio project using Arduino, which I'm going to work on next because I'm into radios. To a typical electrical engineer, I guess. I'm into amateur radio, If you want more information on that, let me know, so I could post things on that too. Lets you communicate to anybody around the country, around the world. It's kind of fun. So let me go to software. You go to software. First I would do is read, let's see, does it have it in the software? Maybe not. Where did I see that? Community, nope, help, store support, resources. Yeah, the resource, on the resources, getting started, I would read that first. Gives you some tips. But to download it, and they kind of walk you through it. They have what I was telling you about, the online tools. And it brings up this software that I'm going to be running. And I want to download it. So go to downloads, and it's going to bring up another screen. And there's also the getting started. You could read that from there. And when you go further down the page, it has a Windows installers for XP and up. And they have a Windows zip file for not admin install. So I'm an admin on this machine, and most of you are admin on yours, so you can use Windows installers. And it says it requires Windows 8.1 or 10. Most people have 10. And it also has it for the Mac OS 10. And it also has it for Linux, which is cool. And that's a whole nother subject, how to use Linux machine. That's used for servers and things like that. I'm also an expert in that. So any interest with that, let me know. I could start classes with that, and it's good to know professionally. There's jobs in that. Okay, so I'm gonna click on the window installer. And to ask you for money if you want to donate. So you could hit it, highlighting contribute and download, or just download. So I'm just downloading it. Click the download. And right now it's downloading the executable. And then I'll run the executable. And it's straightforward. It's going to just install the software where Windows normally installs things, which is on the Windows programs. This is new for this, I believe it's recent. This year or last year they started. Initially, the install was a zip, and then you had to unzip and then run that, and it would ask you where to install. So this is a little more user-friendly. Let's see, while it's doing that, I still got a little, it has 4 minutes left. Let's go back to the book. And actually I could talk about other stuff. 2 minutes left, it's not much. Going back to the kit, these are, I'll show you some of the components on here. This is the important, and on Arduino, they call additions that connect to the Arduino board hats. And because basically, this is the Arduino, this goes on top. You see on here is a little socket. And the thing is when you put this, and this has these pins, so you have to make sure you align it correctly. And this is a sensor shield. It's a generic sensor shield. You can get this on Amazon. I chose generic so that the code is universal also. All these parts are generic. So this allows you to interface with our Arduino easily. You can just attach it directly with wires, but it's a lot more convenient to have an interface because it's numbered and all that stuff. And then this board is a motor controller board. And I'll have more detail on models and all that. And behind this face, you can see this board is the ultrasound sensor, sends ultrasound waves, sound waves, and then it's like a bat. It sends out the sound wave, and then it waits for the echo to return, and that's how it calculates distance. And then it has 2 motors for the wheels, pre-soldered. See, they go into this motor board. And the reason you need another board for the motors is because the motors require more power than usually the board can provide safely. So that's what this does. It provides the power to the DC motors here. Here's another motor, this blue little thing. It's a servo motor, and it makes this thing go back and forth so it could search. And here, this is just a caster wheel just to hold things up. And we're only using 2 motors instead of some kits have 4, because this is a lot simpler and we're covering the same principles. 2 and 4, same thing, it's just twice as complex. So in order for first kit to make it simpler, we just use 2. So the same principle you can do 4 later on. This is a good way to start. All right, so see how my download go. Should be finished by now. All right, it's finished. So now I'll double click on it, double left click on the download. If I see it on my bottom of my screen on the browser, but if you don't, or if it doesn't run from there, it's going to be in the downloads folder of your computer. So here it's saying run, don't run. I want to run it. This is security stuff that the computer has. And here's another one, another security block, which is good. So I'm just hitting OK. I'm just hitting all of the defaults. Arduino uninstall confirmation. OK. OK. And so now it's installing. Oh, actually, it says it's uninstalling. So it's uninstalling the old one, which is cool, and installing the new one. When I did it manually, I did several versions because, like I said, I've been doing this for a while, and I still have to. I'll have to clean up. Okay, the uninstall completed. So now it's going to do the install. Agree, default, install. There it goes. So that's it's extracting, because it compresses the files so they're easier to transport, and then it extracts them, and then it's going to execute them, and that's how the installs usually work. So it's pretty simple. It's not much you need to do, except you be a little patient and wait. And it goes pretty fast, especially since I'm running all this other stuff. While it's doing that, we go to community. Show you what that's looks like. Project Hub, if I can. Having issues with I'll move it away from there. All right. See what are the latest projects. It'll be a few minutes. There we go. So now this, I tell you, it's an international community. So you got all these creative people. Here's a face mask disinfection device. That's pretty cool. They also actually could also make a 3D printer using Arduino. Not this particular Arduino Uno, but Arduino Mega is used for 3D printers because it has more capability. Self-sufficient automated greenhouse. So that's cool. Probably waters itself, turns on the light and all that using Arduino. Hot water heater, thermocouple voltage. Guess it's checking the temperature for some reason. I've seen weather stations. I mean, there's a Corona hand wash timer. That's pretty cool. So there's people very creative, and there's all types of projects. You could look at it, do one of these. You think of your own. I mean, there's also, you can do art projects. I'm working with artists doing an interactive art display where you can like dance in front of our piece, and it's going to have LEDs that follow your movement, which is nice. All right, so there's sky's the limit, pretty much. Limited only by your imagination. And of course, you could build robots. So install worked. So now I'm going to, let me close this. The less stuff I have open, the better it will be. And the book covers also a manual installation in detail. These days, you don't have to really do all that. You can just do what I did and just go to their site and install. It also covers that too. So, and it covers everything I'm doing here. So let me go to the start menu. I'll bring up Arduino. It has that little symbol, Arduino symbol, like a little 8 on the side. And hopefully it'll run. Now, let's bring up this book again. In there, there's a section on Arduino block. Here we go. All right, so Arduino came up. This is the window for the Arduino IDE, which is their development environment. So here you can write your program, just have a little sample sketch to get you started, or a template. You have the two important things is what they call a setup function. You see the word setup with the brackets, and the loop. The loop is where your main code goes. And this is typical like C, C++ style. So there's a first word is void setup. What that means is that function is not going to have any kind of, it's not going to take in any data. It's not going to send out any information. So it's just self-contained. And the same with the loop. So those are just generic, especially the void loop. The loop is required. And you can see there's a bracket kind of pointing to the left. And then you have your line of code or whatever. Here's a comment with the double dashes on the left. And then it ends with the bracket, end bracket. It's kind of pointing to the right. So all the functions, they have like here it says, for instance, setup, bracket, the parentheses. And then it has the other bracket, the curly black bracket, beginning one and end one, and the code in between. And that's the form. And the reason it's like that, because computers aren't like us. Like our brains are so good, so we're so smart that we could just look at stuff and we know what it is. We don't have to do a lot of analysis. But computers are not that fortunate. And also they're limited by the information they get. So they look at every letter, every number, and they go, so they have to have a way. They don't know, like instinctively we know, okay, there's this thing, next line is indented, and it has, so that means it's something different, some information for it. Computer doesn't know that, so that's why it has to have those brackets. The computer can't see it, the brackets will tell it. So we're kind of getting a little bit ahead of ourselves. Here's the computer portion of it. But in order to get people who are not familiar with coding, I'm going to go briefly over the more graphical way of doing this. And this is an add-on. This is not from Arduino, it's from a third party. But it works. Let's see if this, when I did the upgrade, did it install it. Yep, it's something called ADUBlock, ADUBLOCK. And in the book, I tell you how to install it. So I'll show you right here how to use it under tools. And if you'll see, there's a list of things here. And toward the middle, there's ADUBlock. And if I hit that, this comes up, which is similar to what you see in the book. So it has on the left side, it has all your different controls, which translate to functions. So this is going to show you graphically how to put something, a program or sketch together, and it generates the code similar to what you saw before. And eventually, you can just write the code. You know, it all depends on what you're comfortable with. So let's see now, going down this. So here, the first example, I need a loop. So that's that yellow one. I told you that the loop is where all the code goes or sketch goes. So you got to get that function first. So, I see they have a different colors now. So control, is it in there? Yeah, there it is. So there's the loop. Here, I just barely touched it and it went in there. So there's my loop. And it says do. Loop basically repeats. That's why it's called loop. It's kind of circular. And it goes, keeps going, keeps going, keeps going. All right, and we want to, in our case, we want to make a light blink on our Arduino board. So we need something to tell it, we're going to connect the lights connected to a pin. We're going to use internal light. We could use an external one, but we usually do the one that's on here already, LED, and it's already connected internally to the pin. So we have to still define what that pin is. So we got to do the set digital pin. So we go to the pin section, and here's set digital pin. There it is. And we have to move it into the loop. There you go. So if you position the little notch into where the loop has this thing sticking out, it'll automatically put it in. So it already knows pretty much what most people are going to do. So you want to set it up high. Basically, you're giving it like 5 volts. So you're setting it to 1. 1 is typically in computer talk, 1 is high and 0 is low. So we're going to set it up 1 to turn it on. All right, so that's the first page. Now the second step, of this, so let me bring this up more. So delay, okay. I forgot that step. You can set a high and low, and then you probably won't even see it because it's going to be turned on and off so fast. So you want to set it up for a certain amount of time so you can see it. So we're going to put a delay in there, and the delay is in milliseconds. So we're going to do it for a second, which is 1,000 milliseconds. This is metric. So 1,000 milliseconds is equal to a second. So let's go to where the delays are. I lost my stuff. I move this. There we go. So let's see, where would that be under? Utilities, pins. Here we go. Delay. It's on the utilities, delay, and there's delay milliseconds. So I press that. It's already set to 1,000, but I gotta move it under my with the set digital pin function. And here's a notch, goes in there, and there we go. So we got that set. So now we have it to turn on and wait a second before it does the next step. And guess what the next step's going to be? Next step's going to be to turn it off. So in the book, there you go, the rest of the code. And it says, interesting, actually there's a mistake here. I never noticed before. The pin that when you say set pin, this is set pin 1, it should be pin 13 because that's the pin, the internal pin number. So I fixed that. Now let me go set pin. So I'm going to turn it off. So I'm going to do set digital pin again on the pins. Set digital pin. And it's the 1 is default. That's what happened. I left the default. And set 13. And now I want to, you see there's a little arrow up here. It says high. I'm going to change it to low. There we go. That's it. So that's our first sketch. So now let's connect our Arduino Uno to the computer, USB. I'm gonna upload. And you see some lights. You should see lights turn on. That means it's connected. And here you heard that little ding ding ding. That means it's everything good. So let me hit upload. It's been a while since I did this using that board, that Arduino blocks. Let's see, what is our, here it talks about Arduino Sdk, which is software development kit, which is what we're kind of using. And I would think, let me go check if I can. Okay, now let me go to the original sketch. And under tools, what came up first? This should show the board. You should say Arduino Uno. If not, you need to select it. And then ports. It says, and here's why I didn't load. And even though I didn't get arrow, so we should have done this. Look at the ports, and it says this. You see port 19. Port 19 is visible. So let me select port 19. So let me do Arduino block has changed. You want to save? Yes. Saving it as blank. Let me save it on the Arduino files. Okay, so here we go. Function digital write 13 low. We talked about that. It turns it off. Okay, so that's our first code. Now let me try to save this again. Say load. So it should just upload it. It has three things here: save, load, upload. So I saved it, and now it looks like it's uploading. All right, there's a way of testing this. Now, doesn't appear. Okay. Well, anyway, this is intro to Arduino block, and it'll create a code. Now we look here at Arduino. Let's see, would it be on the tools? Was that there? Arduino has also a bunch of canned programs, and one of them is actually that, the Blink program. Arduino, burn, help, tools, auto format, fix, manage libraries. I'm not sure what that is. Oops, that's the wrong page. But what I can do is, let me show you the online. You can do it from there too. I know it has it there. Okay, I'm bringing up the browser. There you go. So let's go to Arduino Cc. Software, online tools. Arduino Web Editor. To do this, actually, to do any of this download and all that stuff, you got to create an account. It is free. So I log into my account. I go to Arduino Web Editor. There we go. It's similar to, you see the code over here. It's similar to the what we just downloaded. Now, examples. So I go to examples. It's loading it. It should show a Blink program. Control sensor gives you all these categories of basics. Maybe. Yep, there it is. Blink. All right, so here's a look at the code here. So same thing I did. Here's a loop. Then there's the digital write, LED built in. That's a variable that holds a number 13 that we put in, and it says high. There's the delay 1000 milliseconds, so that's 1 second. And then it does another digital write, but this time to the same place, LED built in. This time it says low, and that's it. Okay, so now we want to load that thing. So there's this arrow. This on the top of it, there's this check mark. if you click on that, it'll check your code and see if there's any errors. The other one pointing, there's an arrow pointing to the right, that'll check the code and download it to your board. So I'm going to do that, or it says upload. Okay, Arduino Uno, I got an error. That's correct. What about the port? Port should be fine, but there's a way of checking it on here. Error uploading. Check selected board is currently available. Let me do the verify. See, that worked. Done verifying. So the code is nothing wrong with that. Here we go. Now it came up. There's a delay, unfortunately, on this because of all the stuff I'm running. So here, board at COM19 in my case. How to select that and hit OK. Once we select the board, Arduino Uno. Interesting. It was at Uno. I don't know if it. Here we go. Arduino Uno. Rev 2. Hit OK. Now let's do that arrow. Right arrow. Upload. Busy. Gave me a different error this time. Let's try it again. Okay. Executing command, exit 0. Let me hit the reset button on here. There's a reset button. Oh, little things that can happen. It looks like everything's happening. Go off the USB, plug it back in. Now to make, yeah, there it goes. Now it says it's at 19, which is good. Let's try it again. I know that didn't work. So it says did not find device, which is weird. I mean, it could be that I'm having so much stuff running and also using a port. I normally use the other port and I can't switch it now because my camera's on previous port. So that's the next thing I would do is switch the port. Now, all right, so that didn't work too well. Let's see. I'm back on my, it should be over here. I'm back on my screen on my computer. And this happens. That's why I tend to like my own, having it running on my own. So I don't have problems with internet connections or using too much resources, all that good stuff. If I hit the verify here, this should work because I didn't write this code. This is code that came with it. And it's happy. So it's basically functioning. So now I just got to find the code. Here we go, examples. That's what I was looking for. File, it's under file. File examples, basic, the same thing we saw before. But let's see if it works this time doing it locally. So I selected it and here's the code, same thing. Let me hit that right arrow. Oh, let me first look at tools. It says Arduino Uno. The port 19, everything looks good. Hit the arrow, this should work. Any bets? Yay! Done uploading. All right. So, oh, do we see a blinking light? Do you think this light's blinking? There you go. Every second. So you kind of got a taste, unplanned taste of troubleshooting all this. I have had problems, as you see, with the web interface. It should have worked. I'm not sure why. Maybe it's delay because I'm running stuff, but I'm running it from now the code from my laptop and that worked. So unfortunately, we ran out of time. But so tune in next Thursday, 2 p.m. and we'll continue, and we'll go over other stuff. Let's talk about sensors and other programs, the program structure, and all that good stuff. All right. Thanks for joining. Have a great week. Bye.